AI has been investigated to try to, for instance, predict fault in the telemetries. Especially if you use deep learning models, AI might become a black box. So you lose interpretability of the model themselves. There are some exceptions because there are satellites that use some other satellites to send the data, but that's, let's say, a minority of the missions.
Welcome back on the Space Info podcast. Here we talk about space and everything related to it. If you are passionate about space, astronomy, technology and everything about it, you can join all our social platforms at the Space Info Club or our website at www.spaceinfo.club, where tons of content and a community of experts are there waiting for you. This is the Space Info Club. Good morning everyone and welcome back on the Space Info podcast. Today we have a very special guest from the European Space Agency. Today we have Mr. Gabriele Meoni with us. So good morning Gabriele, how are you?
Hello, good morning. I'm fine. Thank you very much for hosting me here today.
That's a real pleasure for us. And so today we talk about a very inflationary topic nowadays, which is artificial intelligence. And we joined the topic together with Earth observation. So we are for sure talking about space and we will be talking about our planet. So Gabriele, what are you doing at the moment? What's your field of occupation?
Yes, so I'm Innovation Officer in the Advanced Concept Study Office and in the Phi-Lab of the European Space Agency. They are both, let's say, two groups of people trying to explore new technologies that might be disruptive in the future. In particular, the Phi-Lab is more focused on Earth observation. My expertise is related to onboard processing, so onboard satellite processing, artificial intelligence for Earth observation application. And as innovation officer, I'm exploring new technology that might have, let's say, disruptive, some potential to disrupt Earth observation application in the future.
So, by the way, talking about artificial intelligence, we all know that it has many applications, and it's been developed along the years. But only in the last couple of years, it came out on the, let's say, wide public. So, how do you envision the artificial intelligence technology as transforming the Earth observation, let's say, from space and in the next decade?
Yeah. Thanks a lot. First of all, let's start by being pedantic on the terminology. In a sense, AI is nowadays it's quite vague terminology, and also let's say the meaning is quite broad depending on the definition. In Earth observation, when you talk about artificial intelligence, you mostly refer to machine learning and even more often deep learning applications. And well, let's say AI is a broad, like a broad plethora of application when it's applied nowadays. First of all, the most immediate one is the fact that AI has demonstrated, let's say, unprecedented capabilities to extract actionable information from Earth observation data. So it's nowadays a state of the art for a lot of applications. A different level from, let's say, more scientific applications, so to help the scientists to, I don't know, predict climate models, or to improve climate modeling, or also for operational services, to predict disaster, or to manage disasters, or there are some applications to also improve, to help policymakers. So the application of AI is quite broad because of that. But also with the now large language model, generative AI, there is also some research trend in trying to use artificial intelligence to help, let's say, non-expert end user to interact with that observation data by creating digital assistants. For instance, this is one of the projects that we are trying to do in the Phi-Lab. And then there is the last trend, or at least of the biggest one, where artificial intelligence has been trying to use onboard satellites to create smarter satellites that react immediately, very quickly, to potential, let's say, anomalies on the data or disaster that you want to detect.
Yeah, so particularly from the last thing you said, it seems to me, at least, maybe correct me if I'm wrong, that we can have a couple of, let's say, different field of application of artificial intelligence or machine learning, if it's a better way to say it. Probably one is the observation of the planet, and the other is, let's say, the orbital mechanics of the satellite. If I'm understanding correctly, not only we will be able to, let's say, to analyze the data that we gather from the observation, but also to improve the, let's say, the orbital slots that we use for the satellite constellation, for example.
Yes, so not only on the mechanics, but also on the operation aspect. So in the way the satellites are operated, in the sense there is a lot of research in trying to make satellite more autonomous from the operation perspective. Nowadays, satellite produce a lot of telemetries, and AI has been investigated to try to, for instance, predict fault in the telemetries and to create smarter satellite that can react to this problem, but also to create novel, let's say, a more efficient way to process the data itself, because the amount of data that is produced is growing over the time, and of course, even the bandwidth of satellite is growing. But it's also for some application very interesting to try to limit the amount of data that you want to send, or when you process in area like ocean, deserts. That's in some operations, in some missions, they don't belong to the planned acquisition areas. By processing the data on board, you could, if you have enough battery, of course, also try to expand the acquisition area by spotting anomalies in the oceans or anomalies in the desert. So you can also change the way you acquire the data because of this potential increased capability to spot interesting things, let's say.
Yeah. While you were talking, I was thinking about, let's say, the operation side, and thinking about the fact that it's, let's say, semi-autonomous technology could take some steps into the decisional chain into the final one. But I suppose that the final one is, in any case, demanded to a human, probably for legal aspects or things like that. We have had some problems of this sort with the orbital satellites in the last few months. So I wouldn't like to come into this topic too deep, because probably it's not the topic of today. But maybe you'd like to tell us some example of imagery analysis and how they can be enhanced and can improve our understanding of our planet, maybe.
Well, yes, of course. I mean, AI has been investigated for a lot of different applications. Not talking specifically about deep learning, but a more, let's say, broader definition of AI, where we have much simpler algorithms, let's say, more trustworthy, probably from some extent. And it is nowadays the state of the art. And when we talk about it, we talk about wildfire, volcanoes detection, or we're talking about also water monitoring to find I don't know, different kind of anomalies there. There is a lot of research to try to find plastic debris there. And when you relate to onboard aspects, of course, this is to be honest, a quite new trend that we are experimenting in trying to move part of the processing on board. So it's not what let's say the typical mission do, but there is for sure, let's say, some trends from the industrial and even the academic partners to explore this kind of new mission paradigms, let's say.
Yeah, I think that this is very, very fascinating. And yeah, probably if we want to go deeper into this topic, I know that people will be listening, will be very curious about, let's say, imagine to put their hands on concrete projects. So maybe you'd like to mention some of the most promising projects which are ongoing inside your agency. I remember that that's the European Space Agency, and conjugating with both artificial intelligence and Earth observation.
Yes. If it's okay for you, I will talk mostly about the projects in my section, so in the Phi-Lab.
Yeah,
that's the
sure.
one I know better. Yes, we have some research, some ongoing projects to explore, let's say, foundation models So, namely, even if the definition there is there's no, let's say, common agreement on the definition. When I talk about foundation model, we are talking about, let's say, big models around at least 1 million parameters, trained in a self-supervised manner without many data, to try to reduce the amount of labeled data. Then we have some research to do, or some industrial projects to do to create a digital assistant, because one of the problems that we have with Earth observation data that is not easy for well, non-technical expert to interact with them to extract information. And you know, sometimes the typical end user just want to have actionable information. They might not want the data. So creating a digital assistant, for instance, with the LLM, large language models, you could try to create a way for this kind of end user, non-expert one, to interact by using, let's say, human language. So this is also a project that we are trying to do. And then we are extensively exploring onboard AI applications. One of the satellite that's been launched last August is called Phi-Lab, and there's actually a satellite with onboard processing capabilities, and the Phi-Lab contributed to this mission by providing our expertise on AI, and by creating a challenge called Orbital AI Challenge, where we selected some application from the community that were uploaded, basically, or will be, sorry, uploaded on board the satellites.
Yeah, I think that particularly the very first thing that you said is, at least in my view, one of the most promising aspects of introducing artificial intelligence in Earth observation. Probably not everyone who's listening is a technical fellow, let's say, of the technology, and we are all used to see beautiful images taken from space, from satellites, usually geostationary satellites of our planet. Okay, they're very beautiful, but from these to the point of having useful data, I think that there is a large gap. And what you were mentioning, in my view at least, is let's say the most revolutionizing aspect of using an assistant which guides. In the end, there's always a human, but it's guiding him into his or her decisions. Maybe he's involved in the industry, not only in research. So probably, yeah. Also, in my view, it's a very promising aspect. So thanks a lot for mentioning. And yeah, maybe you'd like to tell us how did Earth observation change with respect to the early years of satellites monitoring the surface of our planet?
Yes, I mean, first of all, the first change that comes to my mind is due to the technology improvement that leads to miniaturization. No? So if you think about the old satellites, the bigger mission in the past, there were basically missions with very big satellites typically, and whose cost was very high, and because of that, it was quite the access to space was quite limited, basically. So the space agencies has like this kind of central role. Nowadays, with the coming new space due to technology improvements, there's been, let's say, an increased accessibility to space. So of course, space agency still cover quite important role, but there is also mission that are not driven by space agency alone, but also by industries, including academia. There are projects with CubeSat where the same students can also contribute, and then of course this is I think one of the main aspects. And then AI might lead to an additional change in the future. Because of the possibility to move intelligence on board and processing the data, we might have a different way for which satellite behaves. So nowadays, satellites, or at least in the last year, satellites were mostly like eyes, producing image that then were analyzed on the ground. Nowadays, we are trying to move some intelligence on board for which satellite can react quickly and send early alert for disasters, but also communicate each other. And maybe one of the current research trend is exploring novel acquisition systems like tip and queues, where you have two satellites with different sensors that tip and cue each other to enhance the acquisition capabilities, for instance. This is also quite fascinating trend that already some industries and some research centers have started exploring. And this is probably not there yet, but it's a trend that we start seeing, at least in the exploration phase.
Yeah, I think that this is probably one of, let's say, most fascinating, just to use this word again, aspect, because the fact, imagine that you have such a dynamic environment in which different kind of semi-autonomous systems are interacting, is probably one of the biggest potentiality of the whole technology. And so maybe I mean, everything is so amazing on the paper, let's say, but I can only imagine that there can be a lot of challenges, particularly just to remain inside the topic of artificial intelligence when it's applied to Earth observation. So maybe you'd like to tell us more, in particular also to the approach of the European Space Agency, as maybe more specifically, if you'd like, of the Phi-Lab, how it's addressing these challenges.
Yes, absolutely. So there are both technical and non-technical questions. Technical and non-technical challenges. Given my expertise, I will probably mention only technical ones. But so in terms of technical challenges, one of the main one that is not, I guess, shared only with space, but with many different applications, is the fact that, especially if you use deep learning models, AI might become a black box. So you lose interpretability of the model themselves. So that means you gain for some application in performance, but you don't know how, and you don't know why. And this is, of course, a challenge, especially if the application is is related to scientific models, climate models, or things like that, for which you would like, of course, to have interpretability. But also if it's related to operational services, for instance, for which you start sending alerts for which you have to react. And this is, of course, one of the main issue. Another one that is really technical is the fact that to train an AI model, you need labels. So you need image, let's say with a house. If you want to detect if you have a house or not, with terrain with house and not house, and you provide some image, you need to have not only the image but also someone telling you this is an image with house and this is not an image without. This is called labels. And yes, we have so many data, so many Earth observation data, but actually very few label data. And this is an issue because labeling, especially for some application, is quite challenging, require experts. It's quite expensive, it's time consuming, and depending on the application, also quite boring and frustrating. So that's a big issue because for some application, the lack of label data, actually during the development of AI model, there are some studies that tells you that takes more, like the 80% of the time. So this is one of the big issue, and the way we are trying to react to that is for instance, in different way, exploring the so-called unsupervised or self-supervised learning, where the AI model try to train itself without using the label. So it's like a student try to learn without receiving too much feedback from the teacher, let's say. And one of the approaches, the other one that we are exploring, is the creation of foundation models that I said before. But this comes with its own consequences because foundation models, as I told you, are big models. That means creating big infrastructures, computing infrastructure required dedicated expertise to also operate this model, funding for invest to actually create this model. It's also quite challenging because it's always very difficult to understand how much you should invest to try to create a model until you get some novel functionalities, for instance. And then there is also the problem that because of this model are often quite big, they are not, you create this model, they are quite useful, but might be not accessible by everyone because you might need quite powerful computational infrastructure for them. So this is also another challenge that is, of course, worth mentioning.
Yeah, probably the last one is the most comprehensible to the most of the people who are listening. As as everyone can imagine, as let's say the whole internet has grown in the last year, we it's under our under everyone's eyes that the number of servers and computers has grown exponentially to stay at the same pace, probably at the very same. In the very same way, the whole computational power used to manipulate that data will have to grow, or maybe this kind of empirical law will be interrupted and we'll discover different things. But just to summarize the first topic you mentioned for the people who are listening, as you said, it's like learning by ourselves without too much input from the outside. So we have to be sure that what we are learning from the very few information we have, it will conduct us to a predictable, not really a predictable, but let's say a safe path to a desired destination, if I'm correctly understanding. So, okay, so what role do you see the AI playing in optimizing the satellite constellation operation, and also the acquisition strategies? So if there is one.
Well, I may have mentioned it already. One is, for instance, the novel acquisition systems where you have new satellites, or the fact that when you process AI on board, you can discard some data depending on the content, and then this might lead to let me explain this. Like, when satellites need to download the data, they can only do it when they are closed, or, I mean, this is not totally true, but it's true in most of the missions, when they are close to what is called the ground station, so the station that is there to receive the data. There are some exceptions because there are satellites that use some other satellites to send the data, but that's, let's say, a minority of the missions. And is not affordable for all the mission, let's say. And that means you have a limited time, and also, as you probably have experienced with your internet connection at home, you have also limited bandwidth. That means you need to be quite efficient in the data that you want to send. So standard way to send the data, or the current approach, is called band pipe, and is when the satellite is close to the receiving station, you send a command, you ask for the data, you get the data back, and you get all the data. But for instance, you might think that more or less more than the 50% of the data that you have is covered by clouds. And depending on the instrument that you get the image of clouds that might be not really, I mean, I'm not saying that they are not useful, but maybe they are not the typical information that you want. So if you manage to discard them, you can save 50% of your bandwidth to send something else. And one way to do that is moving an AI on board to process the information. And this was, for instance, one of the missions that we did in the Phi-Lab. It's called FreeSat-1. Not only with the Phi-Lab, just to be fair with all the partners, but in the European Space Agency, that we experimented the first convolutional neural network on, let's say, an AI processor to fly on board an Earth observation satellite. This was a 2020 missions, basically. And we did exactly that. We tried to experiment and try to see if we could use AI to detect clouds, basically. That's not the only, we particularly use deep learning, is not the only approach, but we demonstrated it is possible also with deep learning and AI.
Yeah, this actually surprised me quite a lot, because I never thought about this, and probably I think that also the majority of the people who will be listening will think about patterns, pattern recognition. So observe something and say, okay, this is similar to this or that, and labeling, as you mentioned, but excluding most of the images because they are useless, and doing it at the very beginning, so at the source of the data, will save you a lot of bandwidth. And actually, I never thought about this, but that's a very interesting point. So thanks for telling. And to
mention this is not the typical approach that you do, because especially for scientific missions, you would like to get all the data, and this is of course understandable. But you can imagine that if you have a commercial mission for which you cannot afford to have many ground stations, or you need to pay for the ground station, so then especially for commercial mission or mission where you have a very few bandwidth, because maybe you have a small satellite like a CubeSat, with a limited receiver, and you need to share the ground station with other mission, then for this kind of mission can become very interesting. And for instance, if you're not really interested in the clouds, and you can afford to lose some image because AI models are not perfect, and in the worst case you can actually waste some good images, but if you can accept that, then this is something that you can do, for instance.
Yeah, and probably the business perspective on this topic is something that will come into the play in the close future, I think. So you mentioned the efficiency and also the effectiveness of this kind of approach, but can we apply this efficiency, particularly the second one, so the effectiveness, to disaster monitoring and also the promptness in responding to these events?
Yes, so in terms of research, we have we're exploring this quite a lot. There are a lot of exploration in trying to use AI to process the information and to try to do it very quickly. Of course, there are many challenges there. One is related to the fact that to train AI model for disaster, you need to have a lot of disasters in the training set, and so you need to have a picture of disasters, but likely disasters are not so common. So that means to do a proper validation of the model and to train them, you need to collect a lot of images over time, and maybe they are not always available for the same sensor. So there are some challenges there, but of course it's possible. And also, if you really want to react quickly, one of the approaches that you can do is what I was mentioning before. So to try to process the information on board. But there you have another challenge, is the limited amount of power that you have and also time to process the data. So what we're trying to do in the Phi-Lab is exploring the possibility of AI to process the data without much pre-processing, for instance, so to process the so-called raw data. This is not what happens typically on typical missions. So when you have an image produced by a satellite, you typically download it to the ground, and then you do all the fancy pre-processing that you want, because end user wants to clean images. But that's probably not what you want if you want to react quickly to a disaster. So what we are trying to do is to try to see if AI is capable to process raw data. And you can believe me that raw data produced by satellites has a lot of problems. They might have very different sorts of noises due to the fact there's a lack of calibration or lack of image correction. White balancing, if you are familiar with let's say typical cameras that you get, typical images you get from normal cameras as well, and many other let's say also geometrical defects that you get in the image. So because of that, the processing of raw data is quite challenging. One of the research that we are trying to do is AI capable to process this very broad data distribution for which you can even process raw data and learn to deal with this quite noisy distribution that you have. And for some application for which we are publishing results, we are quite getting good, interesting results. And we are shortening so much the time for which you can have a response, at least on the paper. Then we need to see in reality and to make some experiments. But just to let you know, yes, there are some research to that. There are so many challenges, and it's a very fascinating topic, in my opinion. It's actually part of my research topic.
Okay, so congrats, and I hope we will see some results close in the future, because me personally, I'm very curious about this topic. And yeah, so thanks. And yeah, so we have seen that also the whole technology is rapidly advancing. We were talking about image processing. You mentioned also that you need I wouldn't say very specific, but very powerful pieces of hardware. So as everyone can imagine, that's not that easy, going, let's say, up there, changing some motherboards, just to talk very very badly, into a satellite, because you cannot do that. That's unfeasible. But considering this kind of advancement, maybe you'd like to talk about future application for artificial intelligence, and I would like to close let's say the focus particularly on constellations, since we have mentioned that miniaturization and, let's say, cooperation between different satellites is becoming almost a trend. And maybe there is something also beyond strictly Earth observation. maybe not everyone knows, but China is planning to build a constellation around the moon. So maybe we will have some kind of impact also in that sense.
Yeah, I would like to reply to this question by providing a vision that we have, not only in the Phi-Lab, but also in the Advanced Concept Study Office. If I remember correctly, in 2021, we launched a campaign to collect ideas in a topic that we call cognitive cloud computing in space. So this topic envision not only AI on board satellite, a single satellite, but let's say an entire ICT revolution and the AI move on board satellite. So in the vision, you have different satellites that communicate each other, exchange information by using the so-called inter-satellite link. So it's just communication link between satellites, for which you have in some case of distributed intelligence. So not only a single satellite process the data, but actually satellite tips and cue each other, as I was saying before, to generate new acquisition systems or coordinate the acquisition to get maybe advanced monitoring of disaster or different things. Or, for instance, outside of the Earth observation field, there have been some studies exploring the possibility to have a different asset, trying to train on when I say asset, I may mean like a lander or may mean a rover or on Mars, try to train distributed AI model on, let's say, distributed satellite constellation or distributed space assets to try to gather information, maybe for instance on a Mars on a Mars rover, and to try to train it to recognize different terrain features, or also to try to see if you can use different, in the case of Earth observation satellites, to explore different sensors with different say complementary sensors to gather more information about an event. So this is the vision I would like to provide. That's what we really like. I would like to explore in the future, because this actually, if working, might disrupt not only Earth observation, but let's say, as we mentioned in the call, the total space infrastructure.
Yeah, and now that you let us all dream basically about the future, maybe just to make happy also the people who are more concerned about let's say privacy, data security, and also ethical considerations. Maybe we just like to conclude with this topic because recalling what you said in the middle of the interview, you mentioned AI, particularly AI models. At a certain point, after a certain step, they sort of become black boxes. So you give them some kind of inputs, but you cannot 100% predict the output you will get because you don't perfectly know how the model is elaborating this data. So is there any concern about security and also ethics?
Yes, of course. There is also, despite I have to admit, this is not my field. As far as I know, there is a lot of research in this kind of topic. There have been in the past demonstration of possibility to make a deep learning model take completely wrong decision just by injecting noise that is not visible to human, the so-called adversarial attacks. Of course, there is a lot of research. Most of the, let's say, at least with this kind of noise distribution, there were paper demonstrating how to make the AI model more robust. But of course, there are, for instance, security concern in the sense. There are safety concerns because, of course, if you give the AI the possibility to take completely autonomous decision when you have disasters, you might end up in the wrong situation. It also leads to ethical concern. So how to mitigate all of that? Of course, there is a lot of effort to try to make the AI model more explainable, because if you make them more explainable, then you might also understand what makes the AI fails. And there is an entire field of research called explainable AI that's trying to change the AI model, to create new AI model, or to produce new techniques to make, at least to try to understand why the AI model takes some kind of decision. This is mostly applied to deep learning application, but this is one kind of field that goes a bit into this direction, for instance. Ethical consideration, yes, there are one I mentioned before, but I think you also in your discussion sort of provide one of solution. Is not using AI to take, it is not letting AI take a decision, but is using AI to take informed decision. That can be a better way to help us each other, to help us to take good decision when we have disasters, or even using AI to complement other techniques. If you want to get insight for disasters or for application that requires, let's say a human response, just to make sure that we are taking the correct decision. But it's also true the other way around. For the application where the AI is able to extract the features and is the state of the art, is a human more capable than AI models to take better decision? This is also a question that I think we should ask ourselves, and we should give us a response on this.
Yeah, I think that I was thinking about how to better conclude this interview, but I think that we will conclude it with your question. And yeah, maybe it will be interesting if everyone who's listening could tell his opinion or her opinion below in the comments, letting us know what's his thought about this. And yeah, I don't have a very precise question to what you said, a very precise answer to your question. So I just say thank you, Gabriele, for being here. Thanks for this interview. That was very, very interesting. So
pleasure. Yes, thank you very much.
Hope to have you back again soon. Thanks a lot. Thanks to the whole Phi-Lab and the European Space Agency for this opportunity. And I hope that everyone will find this interesting. So thanks.
Thanks a lot.